Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us discuss the today's session about the overview of quicksort. Yes, today we will be discussing about what is quicksort introduction. Then we will be looking into the quicksort algorithm. Then followed by example on by taking some elements on which how we are going to perform the quicksort, and at last implementation of quicksort. We will be seeing how the quicksort program we will write and we will execute them. Okay, let us go for the first step. We will be seeing about the quicksort introduction. Yes. Already we have seen so many sorting algorithms. In that we come across bubble sort, selection sort, then we have seen insertion sort, and we find some disadvantages with these sorting techniques because it is having more time complexity to perform the elements to be sorted in the sorted order, that is either in ascending or descending order. Now let us see why we are going for this quicksort. Quicksort is a famous sorting algorithm and it sorts the given items again in the ascending or descending order, any order we can take. Here it uses the idea of divide and conquer approach. Here we are going to see about what is this divide and conquer approach is. This is the new term where you have seen. Right, we will be seeing about what is divide and what is conquer, and it follows a recursive algorithm. Recursive algorithm also, a recursion you may be studying in your C programming, where you can see what is recursion. Recursion means what and how that will be applicable in our quicksort, that one we will see. And as the name suggests, quicksort is a fast sorting algorithm invented by C.A. or her. This is the person who invented this quicksort. Let us go for what is this divide and conquer. Divide is nothing but we are going to divide the given problem into smaller, but that sub problems are nothing but where you are going to make them as the division of it and solve it, where you are going to have a big problem or a complex problem that is going to be divided into sub problems. You consider 1, 2, 3 and so on, P1, P2, P3. These are the sub problems and these sub problems are going to be solved. These sub problems, for that we are going to find the solution, and at last we are going to combine those solutions to create the solution for the original problem. After doing this, we are going to combine all these and we are going to get the actual solution for the given problem. This is how this divide and conquer is going to work. The same thing it was given, dividing the problem into several problems and then solving the sub problems recursively, and then last combining those solutions to sub problems to create a solution for the original problem. This is called divide and conquer approach. And which of the algorithms? Already we have seen some searching algorithm. There also we come across this divide and conquer. We have seen that in binary search, right? And not only that binary search, we are going to come across this divide and conquer in another two algorithms called merge sort and quicksort also. Now we are discussing about merge sort and we are discussing about quicksort, and later we will be seeing the same methodology we are going to apply for merge sort also. Okay, let us go for the algorithm, what are the steps it consists of, and if we have given some elements, how we are going to apply this quicksort on those elements. Okay, let us see the steps here. In quicksort, partitioning of list is performed using the following steps. What is the first step we need to have? Consider the first element in the list as pivot. Whatever the elements we are going to take in the list, the first element you are going to consider as the pivot element. Okay, but for quick sort, we can't say every time we can take the pivot element as the first element. We can take any random element as a pivot element. But here, for easy understanding, we are taking the first element as the pivot element. We can take the last element also the pivot element, or we can take the middle element, or we can take any element we can take in the list as a pivot element. Okay. Now, let us go for define. What is the next step we need to do? Define two variables I and j. I and j, where it is pointing, I pointing to the first and j pointing to the last of the elements in the list. Okay. Next, increment I until a of I greater than pivot. We are going to increment this I value until this condition fails. That is, a of I greater than pivot, there we are going to stop. And from after stopping I, then we need to go for the j value. This increment j until a of j is less than pivot. Decrement j until a of j is less than pivot, then we are going to stop. That means we are going to decrement this j value. And whenever j and I has been stopped, then we are going to check for the condition if I is less than j. If I and j reaches stopped at some point, then we are going to check if I less than j, then exchange a of I and a of j values. These two are going to be, what are the elements that present in a of I and a of j, those two elements are going to be swapped. And then repeat these steps 3, 4, 5 until I greater than j. Until this I greater than j condition, we are going to repeat the same steps. Then exchange the pivot element with a of j element. After doing so many repetitions, after the elements has been placed or swapped, then at some point you are going to exchange the pivot element with a of j element. When you have done this, when you have reached this particular step, what happens? If you have reached this step, then in the list, if you could observe, if I have swapped the pivot element with the j value, now pivot will be considered is in this position, and left side sublist and right side sublist we need to verify. Left sublist of this pivot will always be less than the pivot element which you have after swapping, and on the right hand side all the elements in the array list or list are greater than the pivot element. This this can be identified that where you have divided the list into two halves. And the same process is recursively repeated on the left sublist and the right sublist also. This is the procedure where we are going to do it in the quick sort algorithm. Let us see with example how this is going to be done. Consider these are the elements where we have 25, 10, 30, 15, 20 and 20. These are the list of elements where we have taken. And what is the algorithm steps we need to remember? According to that, we need to proceed with this example. The first step is we need to read the array elements and identify the pivot element. This is the pivot element which we have taken, that is the first element is the pivot element. Then we need to declare I and j values. I and j is going to be declared so that I is pointing to the first element and j is pointing to the last element. This is done. Now we need to go for the condition if I less, that is I should be incremented until a of I should be greater than pivot. And another one is j, a of j is less than pivot. We need to repeat the steps, right? Based on these two steps or two conditions, we are going to move our I and j values. Let us come and see. Here we need to check these two conditions based on I and j values. Okay. First condition we are going to check. Now I is here. 25 is greater than 25. The condition fails. So that I will be incremented. Now I is pointing to this location. Then You need to check 10 is greater than 25. No, it is not true. Because of that, we are going to increment the I value. I will be here. Now again, we are going to check 30 is greater than 25. Yes. Now 30 is greater than 25. Now we are going to stop this loop. Right. Now go for J. Now you need to check 28 is less than 25. No. Right. 28 is not less than 25. So that we are going to move our J value to here. Now 20 is less than 25. Yes, the condition is true here. So that we are going to stop. Now where is our I value? I value is at this index and J value is at this index. Now you need to check for the case I less than J. What is your I value is 2? 2 less than J is 4. Yes, the condition is true. Now we are going to swap these two elements. This swapping has to be done. Right. Now come down and let us see the same step here. Now what is happening? These two elements are going to be, yes, the same steps which I have presented in the previous diagram, the same thing has been done. These two are going to be stopped, and so that we are going to swap these two elements. We have swapped. Right. Now I is at this position and J is at this position. Now come down. Let us see the next step what we are going to do. Now I and J are at these positions. Now again start repeating the same 3, 4, 5 steps. That is nothing but we need to check I should be incremented and J should be decremented, I less than J or not. We need to verify these statements. Now you are going to check 20 is greater than 25. Is 20 greater than 25? No. So that I should be incremented. I comes here. Now we are going to check 15 is greater than 25. Again, no. So that I will be incremented. I comes here. Next, 30 is greater than 25. Yes. So that I stops here. I is at index 4. Now I is stopped. Now we need to start with the J value. Now check with the J value. J value is how much? 30 is less than 25. No. Again the condition is not true. So J will be decremented. Now 15 is less than 25. Yes. 15 is less than 25. Now we need to stop here. Now after doing this, now you can see here. Now this is the step where you are in. J is here and I is here. Now you need to check for I less than J. What is your I value? I value is 4, is less than J value is 3. Is this condition true? No. Now I is greater than J. Now if I greater than J, what we need to do? We need to swap A of J and the pivot element has to be swapped. Right? Now come down and check where we are swapped. These two has to be swapped. These two are going to be swapped. That means what are the elements you are going to get? 15, 10, 20, 25, 30 and 28. This is how the swapping is going to be done. Let us come here. Let us see what is happened here. 15, 10, 20, 25, 30 and 28. Right? This two has been swapped. Because of that, we are going to get like this. After swapping the pivot element, this one we have taken it as a pivot element, right? This is the pivot element. On the left side or left sublist of the array, you are going to have all the elements are less than 25, pivot element, and on the right hand side, all the elements are greater than 25. You can observe. Based on this, we can split the list and we are going to apply the recursive algorithm on each sublist. Let us come down. Now I have taken the left sublist. You can see here. These are the left sublist elements. 15, 10 and 20. Is they are in the sorted order? If it is in the sorted order, we need to leave as it is. But if you could see, those elements are not in the sorted order. Now what we need to do? Again, the same algorithmic steps what we have, that has to be applied on this left sublist. Now consider again, this is the pivot element. The starting one is the pivot element. And this is my I value and this is the J value. Again repeat the same process. Again check with 15 greater than 15, condition false, so that increment the I value, I comes here. 10 greater than 15, again the condition false, so that I will be incremented, I comes here. 20 greater than 15, yes, the condition is true. Sorry, that condition will terminate. Why? Because 20 greater than 15. Now I is in this position, right? Now come to the next one from J. 20 less than 15, no. So that J will be decremented, J comes to this position. 10 less than 15, yes, here it stops. Now which of the two elements has to be swapped? These two, sorry, which of the two elements has to be swapped? That decides based on whether I is less than J or I is greater than J. Now if you could see I and J values here, if I, what is the I value is 2, is less than 1? No, 2 is greater than 1, that is I is greater than J value. So that we need to swap A of J and A of pivot elements has to be swapped. That means we are going to swap these two elements, so that we are going to get the list as 10, 15 and 20. This is the list where we are going to get in the left sublist. Still we are not gone with the right sublist. We need to complete that part also. Left sublist and the pivot element has been placed in the sorted order. We need to go for the right sublist. Now go for the right sublist. We have only two elements on the right sublist, 30 and 28, but those are not in the sorted order. We need to place them in the sorted order. Now again take the first element as the pivot element. This is I value and this is J value. Now check for 30 is greater than 30. No, the condition fails. So that I will be incremented, I will be in this position. Now 28 is greater than 30, no, right? 28 is not greater than 30. So that what it is going to happen? Still I is incrementing. When you are going to see the J value, I incremented, but we don't have the elements there. Now come to J value. After moving here, I will be incremented and its value has been changed. It is more than J. So that what happens? Now I am going to check with my J value. J is in the same position. If I will terminate, then only we can able to decrement our J value, right? So that we have only two elements. Because of this, what we need to do? We need to I crosses J. I crosses J, because of that I is greater than J. I is greater than J, this condition satisfies here. Because of this case, we are going to swap A of J and A of pivot. So that we are going to swap these two elements. That is 28 and 30 are going to be swapped. Now place all the elements in the order of left sublist and right sublist, 10, 15, 20, 25, 28 and 30. All came into the sorted order. Like this way we are going to perform the quick sort. Let us see, this is where we are going to write a part of code for the quick sort. Let us see what we are doing here. In the quick sort, we are going to pass the array first and last. By using functions we have written this. Okay. Before that we need to read the array element, size of array, all these things has to be passed, where we are going to call the quick sort function, and in that we are going to do this part, right? And when you are going to perform all these cases, first we need to check if first is less than last. First is less than last. If that condition satisfies only, then we are going to perform all these operations. That means we are going to take two variables like I and J. These variables are assigned with first and last, and pivot is going to be assigned with first. These are the three steps where we need to do it at the start. Then, while I less than J, that is I value and J value, or those two elements which you have assigned for first and last, if it is first is less than last, otherwise you can consider. If it is lesser only, then we are going to increment or decrement our J values. For that, while A of I is less than or equal to pivot and I less than last, is this condition, if this condition satisfies, I will be incremented. Otherwise, if the condition, until that condition is true, this I will be keep on incrementing, and if it stops, then we are going to check for the j value, that is, if j is greater than pivot, j will be decremented. Somehow some part or some place it is going to be stopped at this by not satisfying this condition. If I and j is stopped somewhere, then we are going to check with a of I, that is I is less than j or not. If it is there, if I is less than j, then we are going to swap a of I and a of j elements are going to be swapped. If not the case, if my I value is greater than j value, then a of j and pivot elements are going to be swapped. This part what we have discussed this up to this now. Up to that, what is going to be happen? Whatever the list that was given is going to be divided into two sublists, left sublist and right sublist. In between that, we are going to have the pivot element, right? Now, we are going to call the list, the left sublist and right sublist recursively, okay? This is the pivot element where we have, you consider this is the pivot element position. This is the left sublist and this is the right, this from here, this is the right sublist. Now, by swapping with the j, we are going to get it, right? You consider this is the j value. This is the j value. Now, when I am going to call this recursively, and how I need to call the left sublist recursively and right sublist recursively. For that, we are going to call the same function. Recursion means the function calling itself is nothing but the recursion. Now, quick sort of this one, you see this step, what we are doing. You know this is called the first and this is called the last. Okay. Now, quick sort of, this is your array starting address or base address where we are going to have, that is going to be starting with the name A. Quick sort of A comma, this is locating the first position, and until this pivot element is pointing to j, and this is called j minus 1 and this part is called j plus 1. Up to this A to j minus 1 is called the left sublist, and j plus 1 to last is called the right sublist. That is why we are going to call them recursively. On left sublist, we are performing the sorting algorithm of quick, as well as on the right also we are going to do the same. Parallelly, this is going to be happen, right? But I have shown you separately, but this is going to be done parallelly. Why? Because we are going to call these subfunctions, that is functions separately. A comma first comma j minus 1 to here, this is left sublist, a comma j plus 1 comma last is the right sublist. Okay. Based on this, you can able to sort the algorithm. And if you are going to see the time complexity of this quick sort, it is when compared with this bubble selection and insertion sort, it will be taking lesser time for best and average cases, and for worst case, it will be taking big O of n square. Okay. Let us see the implementation part also of this, so that you can understand how this program is going to work. I have opened the online compiler, the same thing what we have discussed. We have already discussed about this quick sort algorithm in the implementation part of it. And let us see the code how we are going to write for this. Here we need to have the header file, and where we are going to call the function here, quick sort function. This is the array, and this is the first and last variables we need to declare. And this is the main function where you are going to write the actual logic, that is where you are going to read the size of the elements or array size, where we are going to read it, and here we are going to read the array elements. And this function, you know that where you are going to print the elements which you have read into the array, that is before sorting what is the list we have. And where this is the function where you are going to call your quick sort function by passing 0 array name and followed by 0 and n minus 1. This 0 and n minus 1 represents the first and last elements in the list, and this one is representing after applying your sorting algorithm of quick sort, what is the resultant sorting you are going to get. That is, the list will be in the sorted order, right? That one it is going to display. And if you see this part, we have already discussed the same logic where we have done it in our done in the example, right? Where we are going to check first and last values, first is less than last or not, and after that we are going to initialize these 3 steps. First and last will be assigned to I and j, and pivot is assigned to the first element. And after that we are going to repeatedly do this process, that is, while I less than j, we are going to check if I is less than or equal to pivot, we are going to increment the I value, and if ij is greater than pivot, we are going to decrement the j value. When these two conditions are stopped or terminated, we are going to check with a of j value, that is your I and j value, that is I is less than j. In that case, we are going to swap these elements, that is of I and j will be swapped. And after that, if this condition fails, then we are going to swap the pivot and the other element, that is pivot and j element are going to be swapped. And this is the step where it is going to split the list into 2 halves, and these are the 2 steps where it is going to work on the left sublist and right sublist. Okay, this is the code. Just run this code and we will check how this is going to work. Just I am taking 5 elements, just in the order of this. Now you can able to see before sorting I have given the elements like this, and after sorting this one, right? Like this way the quick sort is going to work. Now let us see the summary of this today's session, what we have discussed. In the quick sort, we have seen about the introduction of quick sort, and we have come across the quick sort algorithm, like what are the steps to be involved in quick sort and how we are going to assign the pivot, ij values, all these things into this quick sort algorithm, and when you are going to perform the swapping of a of ij, and when you are going to perform the swapping of a pivot and a j element. These 2 things we are going to see in the algorithm. Then we have seen the example of quick sort based on the algorithm, and lastly we have seen the implementation part of this quick sort also. Okay, this is how you can able to learn about the quick sort. I hope you understand this quick sort, and you can able to take the algorithm and you can solve so many examples by using this quick sort algorithm.